the indeterminate forms we use to find the limits, okay? So if you see, when you're plugging the, the function value, and if you see either form, either 0/0 or infinity/infinity, then we call those kind of forms as the indeterminate form, right? So if you see indeterminate form, then you could apply the L'Hopital rule. L'Hopital rule says that finding limit of the rational function f(x)/gx is always equals to find the limit of the derivative of those. Okay. So now if you want to find the limit of this function, when x goes to 2, what you will get? If you're plugging simply 2 here and there, you will get 0/0, right?
Right.
Then you have to apply this. This rule says that finding limit of the function is always equals to find the limit of the derivative of these two. So if you find the derivative of x minus 2, which is 1, the derivative of x squared minus 4 is 2x, right?
Yes.
Now, this is easy to find. When x goes to 2, your answer is 1/4. Now you see the good number, right?
Yes.
So this is very good, useful, application of a L'Hopital rule. So that means you could do this problem in two ways, either factoring or using L'Hopital. Okay. So this section
Yes.
is almost about finding the limits for the, indeterminate form problems. Okay, so I have included several examples. Okay, so you could think about those things. So that is here, but there is another, type of indeterminate problems, which is called the powers of the indeterminate forms. Once you see this kind of, answers in your limit problem, again, answer is, indeterminate form. So either 1 to the power infinity, 0 to the power 0, or infinity to the power 0. These all, don't have a finite answer. So for that reason, again, you have to use the L'Hopital rule. For these kind of problems, you have to, approach in different way before applying into L'Hopital rule. Do some, do some alternate things, techniques to change this form into either 0/0 or infinity/infinity. Do some math to, change these kind of forms to 0/0 or infinity/infinity form. Once you have these kind of forms, you could apply the L'Hopital rules, whatever you learned in the previous section. Okay. So I have explained here, explained a lot of problems, okay? How to use, the power rules. Okay. So let us look at one problem. Okay, I'm thinking, how can I? Oh, okay. So look at this problem: sine x to the power x when limit x goes to 0, right? So now the thing is, if you're plugging 0 directly into this function, what you will get? You will get sine
Uh,
0.
over
Sine,
0.
yes, sine 0 is 0. X goes to 0. So you will get 0/0 form, which is indeterminate. So anyway, you have to use the L'Hopital rule. Now the thing is, you don't have these kind of forms. What you want to do is you have to transform or change this problem into this kind of indeterminate form. How do you transfer? To transfer these kind of things into another way, so you have to use, these guidelines. Okay, what you want to do is um, take the base function as fx, take the exponent function as gx. Okay, that means this problem is in the form of fx to the power of gx. Okay, remember last time I told you e to the power ln of, okay, any function here, any function. So say here I'm taking one function. I already use f and g here. Let me use some different function. E to the power ln of some function hx is always going to be what? So this is one major, the general property of exponential function. Exponential of any ln function is always going to be inside function. Okay. So if you use this property here to this function, you could think of f to the power g as a new function that is equals to hx. That means what? If you apply this result here, you could rewrite e to the power ln of f to the power g function as what? F to the g function. Okay? So this is very, very basic property we have for exponential. If this is the case, now what you want to do? You want to use some log properties. Okay? So now your task is what? Your task is to find the limit of x goes to 0 of that. Okay? So what I'm going to do is, I'm only considering this function. Okay? So limit x goes to 0 of sine x to the power x is always, okay, equals to, right, limit x goes to 0. Now you could think of this is f function, this is g function, this is f to the power g, okay? But f to the power g could be written as like this. So that means instead of these two now, I'm going to replace e to the power ln of sine x, this all to the power x. Do you see why?
Yeah.
Yeah, because of this property. This is equals to e to the power when x goes to limits. So you could put that limit there. Okay. Now your task is to find this piece. Okay. So that one we are taking, let L be the number which is limit x goes to 0. I'm focusing only this piece, right? Forget about E for time being. Only find the limit of this guy. So now I'm keeping that as one number L. Okay, so your task is to find this limit. So now, how do you find these limits? Okay, use some log properties. This could be written as limit x goes to 0. This x could be pulled in front of the log. This is simply the log property. Okay, now this could be further written as ln sine x over, if you move this x to the denominator, you could write like that. You see?
Yes.
Okay,
Yes.
now plugging the limit 0, what you will get? When x goes to 0, you will get here sine 0. So you will get basically ln 0 over 1 over
1 over
0,
0.
which is infinity. What is ln 0? Now think about the log function, ln function. Remember last time we discussed about ln function. You need to find ln 0, right? So ln function is going like that. When x goes to 0, this is x. When x goes to 0, function going to negative infinity. Do you remember? So ln 0 is basically negative infinity. So this is now infinity over infinity form. I'm going to use the L'Hopital rule now because of infinity over infinity form. So I'm going to use the L'Hopital rule. That means what? That means simplifying the derivative of these two functions. Okay. So what is the derivative of ln sine x? X is 1 over x. So your you could think of this as u. So ln u derivative is 1 over u times u prime. U prime is the derivative of sine, which is cosine x, right?
Yeah.
Okay. Now, okay, so now here you will get negative 1 over x squared, am I right? The derivative of 1 over x squared is
Right.
1 over x is negative 1 over x. So you will get cotangent. So it is cotangent x over negative 1 over x squared. Now we will check whether what you'll get. If x goes to 0, what you'll get. So there are a couple of problems. You have to do certain number of times to get the good number. So whenever you get, infinity over infinity, keep on find the derivative one by one and keep on doing. Okay. You see now, again, I'm getting infinity over infinity. That means you have to take one more derivative of cotangent x and the negative 1 over x squared. Does that make sense? Okay, if you want, you could rewrite this as like limit x goes to 0, pull the negative sign outside of the fraction, and
Yeah.
this x squared flipping and going to the numerator, right? And
Yes.
this cotangent could be written as 1 over tangent, so it will be tangent, right?
Yeah.
Yeah, you could do that. Okay, now what I'm telling is when x goes to 0, you will get again 0 over 0. Am I right?
Yeah.
Okay, what I'm telling is whenever you see 0 over 0 or infinity over infinity, keep on finding the derivative, right? So I am
Right.
doing one more time finding the derivative. So what is the derivative of x squared?
2x.
2x. What is the derivative of tangent x?
Uh,
Yes. Now plugging 0, you will get good number. What is that? Secant 0. What is secant 0? Correct. It is 1. Cosine 0 is 1. So 1 over cosine 0 is 1 over 1,
Yes.
which is 1. Okay.
Okay.
Okay. So when x goes
Right.
to 0, the numerator will be 0 over the denominator is 1. This is a good number, right?
Yeah.
Okay. So you are getting 0. What was that? That was my L. You remember? I'm finding L, right? The exponential piece. So we got the answer for L. L is simply 0. That means if you plug in here 0, you will get the final answer. This is the actual problem we are working on, remember? So
Yeah.
the actual problem can be written as e to the power of limit of that. Limit of that is now 0, we got. Therefore, the final answer is simply e to the power that L. Okay. Therefore, the final answer limit x goes to 0 of sine x to the power x is nothing but e to the power L. But now L is 0, so e to the 0, which is 1.
Right.
You see now? So that's what L'Hopital rule says. So I have included so many problems here you could work on and, try to understand these steps. Okay. The key point is look at the problem. Whenever you see this kind of indeterminate powers, use the ln of the given problem like this. Write down with ln of the given problem, then try to find that limit by putting into fractions like I did here, numerator and the denominator, and check whether you are getting either 0 over 0 or infinity over infinity. Once you get that form, simply find the derivative of both. Do the uh, follow the procedures until you get a good number like this. Yeah, there are several ways. Yes, that is also one indirect way of applying the L'Hopital rules, the one you are talking. Yes, you will get the same answer. Okay, so that is about using the L'Hopital rule 5.6. Now 5.7 is simply the talking about the inverse trig functions. Okay, so
Yeah.
this is just the inverse of the function, right? Remember, suppose if you are given a trigonometric function, say sine x. Remember x? Remember here, x is the
Yeah.
domain, right? This domain, normally we have an angle, right? So you could
Yeah.
use either degrees or radian, right? For example, if you want to find, say, sine of pi over 2, we know now this is in radian, basically 90 degree. So you will get the answer, which is 1, right? So the range is y and the domain is x.
Yeah.
Okay, so the domain of sine function is, remember the sine graph. Sine graph is oscillating like this. So this domain of sine graph is, this is domain line going all the way from negative infinity to positive infinity. But the range is y value. So range of the sine graph is the smallest value you will see negative, or the highest value is 1, and the smallest value, this picture goes like this. Smallest value is -1. Therefore, the
Right.
range, the range of sine x is the possible y values, which is -1 to 1. Okay, this all you already learned about, drawing sine graphs, trigonometry. But here you are talking about the inverse of the trig function. Okay, so the inverse of any, for example, sine x could be written in two different ways. Some book use, arc, right, sine. Some book use to the power -1 for the inverse. Okay, so you could use either way.
Yeah.
So no confusion. This is not negative power 1. This is inverse notation. Okay, no confusion, right?
Right.
Okay, so this is just an inverse notation. So this is not equals to 1 over sine x. So you should not interpret in, mistaken way. This is not correct. So this is just a notation we use for the inverse, like a -1 power. Okay.
Yeah.
So you could use either one. But here, if you have a function, say you are given arcsine function. Now this is nothing but the inverse of sine function. Again, this is also a function, right? Now, for this function, the domain is going to be what? The domain is basically going to be the range of the sine function. You have to, flip around the domain and the range for the actual function,
Right.
to
Yes.
to define the domain and the range of the new function, which is inverse function. So if you look at here, the definition, it says clearly, right? Now you see the domain of this inverse function, that is -1 to 1. Why it is? Because the range of the sine function was -1 to 1. So the range of the sine function is basically the domain of the arcsine function, inverse function. So I have to flip around and check. Make sense?
Yeah.
Okay. But for the range of the inverse, right? The range of the inverse, normally, the range of the inverse function supposed to be the domain of the original function. The domain of the original function is actually negative infinity to positive infinity. But remember, we restrict our range to -π/2 π/2 without considering all the values. We simply, restrict our domain as -π to π, -π/2 to π/2 for the original function. Then flipping around, we use this because to preserve function as, one-to-one function. Okay, so you will learn those things, deeply in Cal 2. So at this point, you just look at these things. Okay,
Okay.
right. So that's what they have explained here. You see now. So even though the domain of sine function is all the way -infinity to positive infinity, we simply restrict the domain to -π/2 to π/2. So you will consider only this piece for the inverse function. Okay, that's what everything is explained here in clear way. At this point, you just look at these graphs. This is all about, inverse functions graph. Simply flipping around the actual graphs: sine, cosine, tangent, secant, cosecant, and cotangent graphs. Okay, so these are simple problems they will ask you to find out. Okay, now tell me, evaluate the function value. You need to find the answer. Remember, now you are flipping around, right? So your answer of the given problem is nothing but an angle. Do you see that?
Yeah.
Because this is inverse function. Inverse of the value will give you the angle. Earlier you had what? The function has the angle, then you found the value. Now value is inside because of the inverse. Okay. So the question is now, you are asked to find arcsine of -2 over square root 2. What does mean by this? This means they are asking, hey, sine of, suppose say this answer is, say x, I don't know answer, right? So normally we use y, right? Because function value is y. Suppose I'm asking you if the answer is y, what does mean by that? That means question is like this. Hey, if you put y, what value for the angle, you will get negative 2 over 2. You understand the question?
Yeah.
Yeah. So basically, you are finding an angle whose sine value is negative 2 over 2, right? But remember, your y, your y is should be between negative pi over 2 to pi over 2 because we restrict our range. You see now
Yeah.
for the sine. So whenever you are asked to find the inverse function value, that is nothing but the function value. That function value is range, so it should be negative pi over 2 to pi over 2. Okay. Now use the unit circle technique and tell me for your y should be negative pi over 2 to pi over 2. Where is that? That should be either first or fourth quadrant. Am I right?
Yeah. I would say quadrant 4.
Yeah. Why it is quadrant 4?
Well, it's sine is negative.
Exactly. Sine is getting negative answer, so your answer is supposed to be here. First quadrant always positive. Okay, sine of which angle should be negative 2 over root 2?
7 pi over 4, or let's say 8, 7 pi over 4.
You are very close, but 7 pi over 4, even though this is giving sine negative, but this is not correct because your answer is supposed to be in this range. 7 pi over 4 will be somewhere here. Am I right?
Oh, yeah, yeah.
So always look your answer within this range. Understand? Even though your answer is correct, you could write, I know, sine of 45 degrees 2 over root 2. Am I right?
Yeah.
But now you are looking for the negative, therefore your answer is simply negative pi over 4. Now look at sine of negative 2 root 2 over negative 2 over root 2. Do you see that?
Yeah.
Your answer is correct, but this is not in our range. Our range is here, pi over 2 to negative pi over 2. So look for the answer within this range. But this value is not in this range. Do you understand?
Oh, yeah.
Because
Yeah.
if you figure out this is not in this range. This is out of this range.
Okay.
Yeah, that's what we restrict our range because to avoid these kind of things. Always you will find only one answer whose sign value is negative 2 over root 2, which is negative pi over 4. Okay.
Yeah. Yeah.
Now go to the second one. What is arc cosine 0? We don't know answer. Say y. The question is now finding cosine y should be 0. But remember again, your y should be O. Now look at the cosine function. For the cosine function, what was your range now?
0 to pi.
0 to pi. So you have to always look for the range. So you have to tell me the answer. Cosine of which angle will give you 0? That angle is supposed to be between 0 to pi. Cosine of what is 0? It is pi over
Pi over
2.
2.
Cosine
Right.
pi over 2 is 0. We are now good because this answer in this range, 0 to pi, right?
Yeah.
You see now, like that, you have to find out, the possible range for the inverse function. Let me go through these two very quickly. Okay. Now again, we don't know answer. Say why. The question is tangent of which angle should give you 1. Okay. Now tell me the range of the tangent graph. Where is that? This is tangent graph. What was the range of tangent? Like sine, right? But only difference is in sine we include the endpoints, but for the tangent we have just an open interval. We cannot include these two because remember, tangent function is undefined at these two. So you will not find any good number. So your answer y is supposed to be open interval, negative pi over 2 to pi over 2. Now tell me, tangent of which angle will give you 1 in this range?
Pi over 4.
Very good. You are good now. You are understanding now, right? Getting better and better. Okay. The last problem. Oh, this is now not a good number, so you have to use the calculator, okay? Cosine of y should be 0.3. Okay, now ask yourself, what is the corresponding y value? Remember, your y should be, now problem is cosine, so 0 to pi. Am I right? Remember, your y is in radians, 0 to pi. Pi is 180 degree.
Right.
Do you see that, William? Okay, now tell me, this is approximately how many degrees? 1.26 radian. How do you change radian to degrees?
Mode.
Simply multiply the radian answer by 180 over pi. Okay, so I'm using the calculator now. 1.26 multiplying by 180 divided by pi. Where's pi? Do you see pi here?
Yeah, right there.
Yeah.
Right there.
How many
Yeah.
degrees? 72 degrees.
72.54.
Yeah, 72.2 degrees. So if you find the cosine of 72.2 degree, it will give you 0.3 answer. Makes sense, right?
Yeah.
Okay, so now this is the way to find the angles. Okay, so these are some properties you could read. Okay, our key point is now finding the derivatives of, inverse function. So you have to memorize these formulas, okay? Suppose u is a function of x, okay? So the formula says that the derivative of arcsine u is simply what? 1 over square root 1 minus u squared times u prime. The cosine is the same thing, but you will have the negative sign. Arctan derivative is u prime over 1 plus u squared. Okay. Arc cotangent u is again negative of tangent. Secant is u prime over absolute u times u squared minus 1. Okay. This all, if u is a function of x, right? If you replace u by x, you could rewrite all the formulas in terms of only x. If u is x, then what is u prime? U prime is simply 1. So if you're plugging these two values into this all formula, you will get what? The derivative of sine x, sine inverse x. Simply 1 over square root 1 minus x squared. This is the basic formula I'm writing here. The derivative of cosine inverse x is same thing but negative. The derivative of tangent inverse x, 1 over 1 plus x squared. Okay, so then the derivative of dx of cotangent x, cotangent inverse x, same thing for the tangent but negative sign. You see that? Then derivative of secant x inverse, secant inverse x, it says that 1 over, you have absolute u there, right? So you will get x squared minus 1. And you see here,
Yep.
Okay. So basically you could, memorize these all. Okay. Suppose in the problem, if you see here, other than x, then use those function as u. Then use the formula here. This formula here, given formulas are set of common formula, right? You could be any function of x, but here I have written special functions all in x. Do you see that?
Yeah.
Okay. Now look at this problem. For example, the first one, you are asked to find the derivative of arc sine 2x. Right? So
Yes.
inside the arc function, now you have other than x, keep this as u. So now use the first formula. If this is u, then what is u prime? U is 2x.
2.
What is u prime? Simply 2, right?
2.
Then
Yeah.
use this formula. Replace u by 2x. So you will get u prime, which is 2, over 1 minus u squared. Your u was 2x, so 2x squared. Do you see that? So then after that, simply use some algebra to simplify the problem. You understand? So basically we use here chain rule, right? Okay, that is there. Now let's move to that practice test problem. You see, these are the problems, finding the derivatives. Now you should be good. What do you want to do? I'm giving hints. Use the inside function as u for all the problems. Oh, okay. So I'm going to discuss the last one, okay? Part D.
Yeah, that's what I had a question on.
Okay, no problem. I'm going. But I used to prefer to write down like this instead of arc, but both of them are okay. Right. Finding the derivative of this function. Okay, tell me what kind of rules you want to use here. What do you see there? First of all, you need to use the product rule, right? You
Yeah.
see, there are two functions now multiplying over each other, right? So you could think of these as function f, this as function g. That makes sense?
Yeah.
Okay, recall your the product rule formula. Let's see who's remembering. What is the
F.
derivative of product rule? F times g, f times g prime plus g times f prime.
F
Yeah,
prime.
you are
Right.
also correct. Yeah, f prime times g. So I'm using this formula now. So f times g prime, our f was now x times g prime, the derivative of g function. This was my g function. Plus g times, g is my inverse function. G times f prime, f was just x, therefore the derivative of x is 1. Now what is our task? Our task is to find this guy. What is that? The derivative of arctan x squared over 4. Here you have to use the u substitution technique, right?
Yeah.
Okay, now I'm going to use u as what? U as the inside function. So our u is here x squared over 4. If this is the case, then what is u prime? Listen to my question. Your u is x squared over 4. What is u prime? Hey, what is the derivative of x squared?
2x.
2x times 1 over 4, which is x over 2.
Oh.
Okay. So now I am finding the derivative of arctan u. X is here, x is here. Now I'm going to write the derivative of arctan. What was that? The derivative of arctan u. Formula says what? The derivative of arctan u here, right? U prime over 1 plus u squared. U prime is now x over 2 over 1 plus u squared. U is this. U is x squared over 4, but u squared, you have to square that. This is the answer you get for what? Arctan x squared over 4 derivative. Plus, now write down this piece. 1 times that function is simply that function. Okay, now you have to use a little bit algebra and simplify it. So let us simplify. X times x is x squared over 2. Here you will get 1 plus x to the power 4 over 16 plus arctan x squared over 4. Now, what was the answer I gave? Did I simplify the answer? Okay, so that means we need to simplify this. So x squared over 2. The denominator will be simply, put 1 here and cross multiply and combine these two. 1 times 16 is 16, plus 1 times x to the power 4 is x to the power 4, everything over 16. Now you need to flip these two number out. 16 will go up, 2 will come down, right? So don't forget to write down the remaining piece. Okay, will you get now that answer? 2 gone, you will get 8. Okay, simply use the formula. So again, use here u, this was u. Okay. So anyway, I'm going to erase this now. So you will have the video. So you could copy down the answers. Are you following me? Both of you? It's L'Hopital rules, right? How can I use L'Hopital rules? Whenever you see the problem, when you do the limit problem, if you see 0 over 0, infinity over infinity, 1 to the power infinity, 0 to the power 0, or infinity to the power 0, right? It's all in determinate forms. You have to use the L'Hopital rules. Okay, tell me now, when you plug in the limit, what kind of forms you will get the first problem? 0 over 0 form. So you have to use the L'Hopital rule. So very easy problem that was. The actual question was finding the limit of a tangent 2x over sine 3x. Okay, so now I'm getting 0 over 0 form. Therefore, the finding the derivative of two functions now. What was the derivative of tangent 2x? Okay, so this over the denominator derivative, you will get 3. The derivative of sine is cosine 3x, right? Now plugging 0, check whether you are getting good number. Cosine 0 as well, so you'll get 1 over 1. Yes, I'm getting good number. And that is not harder. Part B, finding limit x goes to 0 of ln 1 plus x squared over x. What kind of form now you will get when x goes to 0? Again 0 over 0, because when x goes to 0, you will get ln 1. ln 1 is 0 over 0. So again, use the L'Hopital rule. Find the derivative of top and bottom separately. Finding the derivative of top, the derivative of ln, you have to use u substitution. The derivative of ln u is 1 over u times u prime. The derivative of 1 plus x squared is 2x, right?
Yes.
Over, the denominator is just 1. So if you simplify further, no, if you're plugging 0, you will get good number at this point. Oh, that is a good number.
Yeah.
Nice. That is also easy problem. See, finding limits, x goes to infinity now. 1 plus 1 over x to the power x. What kind of form now you will get? Now, if you see, this kind of indeterminate, you have more work now, right? We did similar problem. You have two functions. One is at the bottom, another one is at the top, right? Power function. So what was the guidelines we had? Remember, you have to think this function like f function, power function as g function, right?
Yeah.
So that means you have to consider the limit, say L, limit of the given limit was x goes to infinity. Now you need to find what limit? Limit of ln function, ln of f to the power g. So f was 1 plus 1 over x and g was x. So simply find the limit of ln of the given problem. That make sense?
Yeah.
Okay, denote that answer as L. Now your task is to find this limit. How do you do that? You have to use the log properties before putting into the limit values. So this is the limit x goes to infinity. I am, pulling this power in front of the log. Okay. Now what was the steps we were doing earlier? You have to move this x to the denominator like this, right? Now what kind of form you will get? Now plugging infinity into this function, what you will get? When x goes to infinity, 1 over infinity is 0. 1 plus 0 is 1. ln 1 is 0. 1 over infinity is 0. You have now 0 over 0 form. Yes, now you are good to use L'Hopital rule from here to there. Now use the L'Hopital rule, right? What do you want to do? Simply find the derivative of top and bottom. Okay, now your task is to find the derivative of top and bottom. What is the derivative of ln 1 plus 1 over x? You have more work now. You have to keep this as u, right? So what is the derivative of ln u? The derivative of ln u is 1 over u, where u was 1 plus 1 over x, times u prime, the derivative of 1 plus 1 over x. What was that? The derivative of 1 is 0. The derivative of 1 over x. What is the derivative of 1 over x? The derivative of 1 over x. I'm asking you d over dx of 1 over x. You are very close. Negative 1 over x squared.
1 over x squared.
Now go to the denominator. Again, I have here 1 over x. What is the derivative of 1 over x? Again, 1 over negative 1 over x squared, right?
Yes.
Now you see two same guys. You could cancel. Do you see that?
Yeah.
Now plugging the limit. Now plugging the limit. Check the value. 1. That was my L. So we got very good number L. Once you find L, we are good to write the final answer. Remember the original problem was what? The original problem was finding limits of 1 plus 1 over x to the power x. Am I right? This was the given problem, no?
Right.
That is equivalent to e to the power L. Always you have to put e here, right? Then the number L just now we got, which is 1, no? So answer is what? E to the power 1, which is e. That makes sense? Oh, this one, you were asking about this question, right? So the hint is, okay, let me go through that here as well. Others all can see, right? Okay, for part D, question was finding limit x goes to 0 of e to the x plus x to the power x. When x goes to 0, e to the power 0 is 1. 1 plus 0 is 1. So you will get 1. 2 over 0 is infinity. So you will get 1 over 1 to the power infinity form. That means you have to use the L'Hopital rule. So this is, again, you could think of f function. This is our g function. So you have to consider always L is equals limit x goes to 0, the given problem of what? Of always ln of the given problem. Now again use the log property. This is going to be 2 to the power x could be pulled out. ln e to the x plus x. Now if you plug in 0, you will get again ln 1 is 0, 0 over 0 form. Now you are good to use the L'Hopital rule. Now I am using L'Hopital rule here. So that means limit x goes to 0 of finding the derivative of top and bottom. So 2 is the common number writing here. I'm going to find the derivative of top ln. It is 1 over e to the x plus x times, okay, I'm using u substitution. U is e to the x plus x. So ln u is 1 over u times u prime, the derivative of inside function, e to the x plus x, which is e to the x plus the derivative of x is 1. Now go to the bottom, the derivative of x is simply 1. Now if you plug in 0, you will get good number now. This 2 is here. When x goes to 0, e to the power 0 is 1. 1 plus 1 is 2 over. Here you will get e to the power 0 is 1. 1 plus 0 is 1 over this 1. So that is going to be again 1. So this is 4. So I got L, very good number, which is 4. Therefore, the final answer, limit x goes to 0 of e to the x plus x 2 to the power 2 over x is always e to the power that answer. Okay. Now this one I already explained in the previous video, so you could watch there. Okay.
All right.
Again, here also I'm giving some hint. Use the U substitution. Okay, then you should be good. Okay. So here use U as 1 over x squared. Here use U as square root x. Here use again U as 1 over x. Here use U as e to the x minus 1. Then use the U substitution, you should be good. Do you want me to do any problem out of these four? I could oh, I think one of these problem we were discussing last time. Is it correct or not? I was
Uh,
talking. I was talking about. Oh, I was talking about on the note. Okay, tell me which problem you want me to discuss today. This is definite integral. You have limits. Okay, so normally we have to use the U substitution to the complicated function. Here the complicated function was inside the square root. So I'm keeping e to the x minus 1 as u, right? That means what? Our task is to change all the x variables into u variables, right? So that means you have to change the integral in terms of u, therefore you need here du. But you have the relationship between u and x variable, so simply find the derivative of both sides. The derivative of u is du. What is the derivative of e to the x minus 1? With respect to x, e to the x derivative is e to the x, the constant derivative is 0. So therefore, this is e to the x times dx. Okay, you see now, e to the x times dx, I see here, e to the x times dx is equivalent to du. So this is basically equals to du. That means your original problem can be written as, okay, I'm considering for time being without limit, okay? So I'm just finding the answer for without limit. So this is equals to, this guy is now square root u, because my u was e to the x minus 1, right? Times e to the x times dx was my du. So problem is very simple now, which is du. Okay. Now we know how to find the antiderivative of square root u. This is nothing but u to the power half. Use the power rule for the integration problem. This is u half plus 1 over half plus 1, right? That is u to the power 3 over 2 over 3 over 2. Now I'm going back to original variable. U was e to the x minus 1. Therefore, u was e to the x minus 1, but I have u to the power 3 over 2. Over 3 over 2. Okay. Now I'm going to plug in the limit. Remember, the actual problem has the upper bounds and lower bounds in terms of the variable x, 0 and 1. Now I have the answer for 0 and 1. Now I am finding the final answer. Okay. So remember the way I'm doing here, even though problem has, definite integral, I first consider, without the limit and do the problem. After changing back to the original variable, now you write down the problem with the limit, the actual problem, okay? The actual problem, 0 to 1, e to the x, square root of e to the x minus 1 times dx. So this is now equals to, I did the hard work, I got the answer, e to the x minus 1, 3 over 2 over 3 over 2, now plugging the limit 0 and 1, okay? In this way, you don't want to change, the variable bounds to the new variable, because I did not use new variable. So I'm just going and, replacing by my old variable. So I'm putting the all the, bounds. Now you know how to find the bounds. So you have some algebra. This is nothing but 2/3 if you flip the fraction. Now plugging the upper limit first here. If you're plugging upper limit here, you will get e to the power 1, which is e minus 1. These all have the power 3 over 2. Then subtract the, the value of the upper bound, the lower bound. So which is going to be e to the power 0 is my lower bound minus 1. Remember, e to the power 0 is 1, 1 minus 1 is 0. Therefore, your answer is 2 over 3 times e minus 1 to the power 3 over 2. Is this the answer you have? Yes, good. Do you understand how, we change to the new variable u and going back and plugging? Okay.
Yeah.
So all three has different format here. So once you find the du, you will come out with, exact factor, whatever you have in the original problem. Okay, this should be easy. Oh, I think you don't need to do this. You don't want to do this because at one point you have to use some different formula you did not learn 5.3. So please don't do that. Okay, so only do A and B.
Okay.
Okay, that's it. So now this all, you know how to do that. I explained already, guys. Find out, these angles. So I'm discussing this one, B. So the question is finding the secant value of arc sine of negative 1/3. I don't know answer of this. I'm just, you see now, this is the way. I'm keeping inside function with the arc as my y. Okay, so let y be arc sine of negative 1/3. Okay, if this is my y, that means your actual problem is finding secant of y. Am I right? So now your task is to find your task is to find secant y. But this relationship says that, arc sine means inverse, right? So if you switch these two, this expression says sine of y should be negative 1/3, am I right?
Yeah.
Okay, now if you look at, you know, 3 over 2 square root 2, right? Now you need to multiply by 2 here and there, square root 2. Yes, now we are good. So we are getting correct answer. So in this manner, you could think about why I do not prefer to put here negative sign, William, because we are talking about the distance, so we don't put negative there. You know?
Right.
Yeah, that's what I just consider without the sign after finding the answer. Then you have to choose the correct
Right.
sign. Yeah. Okay then. So